Okay, now the another part of sequence and series that today I am taking the new topic, that is geometric progression, that is GP. Here some important points are here. Geometrical progression means it is known as a GP. The definition of GP is a sequence of non-zero number is called geometric progression if the ratio of a term and its term preceding to it is always a constant. Means a sequence when we are multiplying or divide equally, that is a GP. For example, now you can see the first sequence, it is 2, 4, 8, 16 and so on. It is moving on. Okay, you can see here we are multiplying 2, then it will come 4, then 2, 8 to 16 and so on. Okay, and in another here we are dividing by 3. So 27 divided by 3, 9 divided by 3, this, and divided by 3, it is 1. Okay. So it is multiplying or dividing by constant number. Okay. So this type of sequence is known as geometrical progression. There are some formulae are here. Okay. Nth term of GP, this is symbol An is equal to A r to power n minus 1, where A as the first term and R is the common ratio. R is the common ratio of two, the term to preceding term, and n is the number of terms. And suppose that last term is given here, we can find the nth term from n upon r to power n minus 1. Now selection of some terms. If we want to take the 3 terms are in GP, so these 3 terms would be A upon R, AR. Here we can see that R is a common ratio. Multiplying R become A, then multiplying R become AR. Similarly, if we take the 4 term in a GP are in GP, so we will take A upon R cube, A upon R, AR cube. Here R square is a common ratio. And now if we want to take the 5 term RAP, so now it is the extension form of these 3 terms. Okay, you can see here A upon R square, A upon R, AR square. Okay, after that the next thing is sum of n term. You want to find the sum of n term, SN. So this is the AR to power n minus 1 upon R minus 1. This is a condition given here when value R is greater than 1. If value R is less than 1, the formula become Sn is equal to A bracket 1 minus R to power n upon 1 minus R. Also there is a one formula of sum of infinity term of GP. So infinity term S infinity is equal to A upon 1 minus R. And that is the one of the important condition of GP or property of GP. If A, B, C are in GP, so B square is equal to AC. It comes from here like A, B, C are in GP. So ratio term to previous terms is always equal to B upon A is equal to C upon B. So cross multiplication, so B square is equal to AC. It comes from this side. Okay. These are some important points and formulae of GP. Now I'm taking some questions starting from very easy questions. Okay. Now question is, there is one series 1 upon 4, 1 upon 2, minus 1 upon 2, 1 minus 2 and so on. Find a ninth term. Okay, starting is very easy. Now first always we find the first term, which is 1 upon 4, that is given here, and ratio. To find ratio we always divide n term by its preceding terms. The minus 1 upon 2 divided by 1 upon 4, it means minus 1 upon 2, 4 by 1, that is minus 2. Okay, so this is the common ratio R. And we are going to find the ninth term, A9. A9 means AR 9 minus 1. AR 9 minus 1, it means AR 8. And now A is 1 upon 4 and R is minus 2 to power 8. So 1 upon 4 and 2 to the power 8. It is positive 2 to the power 8. And finally, it will be 64. One another question I am taking. There is one GP is given here, that is 2, 1, 1 upon 2, 1 upon 4, and they are asking which term of GP is 1 upon 128. Okay, now we have to find the number term whose terms, the value of terms is this 128. Always find A first, R second, R is 1 upon 2, divide 1 by 2, and now let this is the nth. Suppose it is the nth term, so an is equal to 1 upon 28 and n is the question mark. We have to find the value of n. Okay, using formula A R n minus 1. Okay, so value of an is 1 upon 128, a is 2 and r is 1 upon 2 to power n minus 1. Further calculation, okay, and now it is 1 upon 128 and 1 upon 2 to power n minus 2, okay, plus n minus 2. And this is the 1 upon 2 to power 7, 1 upon 2 to power 7, and this is 1 upon 2 to power n minus 2, and we will compare n minus 2 is equal to 7, n is equal to 9. It means the value of ninth term is 1 upon 128. Some other application questions are we are going to solve. Application questions are one of the questions. Find the GP if sum of first two term. Question is sum of first two term. That means A1 plus A2. This is the condition given. Sum of first two term is minus 4. This is the first condition. And now also the fifth term is 4 times. Fifth term is 4 is the 4 times of third term. 4 times of third term. This is the second condition. These two conditions has given here and asking find GP. So what they are given? The sum of first two term A1 plus A2. A1 plus A2 is minus 4 and the fifth term is 4 times of third term. So find the GP. So using the now form equation, A1 plus A2 is equal to minus 4. A1 is A and A2 is AR. First term A2 AR 2 minus 1 AR. Take A common. Okay. Make another equation. Okay. And after that now A5. Second A5. That means AR to power 4. AR to power 4 is equal to 4AR square. 4AR square. So A or A cancel and R to power square. This cancel 2 values. R square is equal to 4. And R, it means R is equal to plus minus 2. R is equal to plus minus 2. And now we will put the value of plus minus 2 here in first equation number third. Equation number third. So we will get the value A is equal to minus 4 by 3 and 4. So now we have it. So GP would be, so after putting this value in equation 3 here, 1 by 1 plus 2 and minus 2. Okay, and we will put plus 2 here to this. So now series become minus 4 by 3 minus 8 by 3 minus 16 by 3 or 4 8 64 minus 8 and 16 and so on. So there will be two cases, two answers will be here. Okay. One other interesting question we are going to solve. Let Pth, Qth and Rth term of GP is ABC. Similar type question we did already in AP also. The Pth, any AP is A and AQ is B and AR is C. Okay, value of Pth term is small a, value of Qth term is small b, value of Rth term is small c. Then prove that A Q minus R into B R minus P into C P minus Q is equal to 1. So now from first three condition we will take the formula AR P minus 1. Here we are taking first term as a capital A and common ratio capital R, because already A word is using here, that's why. This is the first condition. Similarly, second, AR Q minus 1 is equal to B, and same in third condition, AR R minus 1 is equal to C. Okay, after that now we will put these value of A, B, C from here to this LHS. Now taking as here. So value of A is AR P minus 1 and the whole power is Q minus R. Similarly from B part, this AR Q minus 1 R minus P and AR R minus 1 P minus Q. Further calculation, okay, A to power Q minus R, this power will separate to both A and R, and R to power P minus 1 Q minus R, A to power R minus P and R to power Q minus 1 R minus P, A to power P minus Q and R to power R minus 1 and P minus Q. Okay, further on calculation here, we will take A, these three separate, okay, here. So, the power will add Q minus R plus R minus P plus P minus Q. And also in this R, P minus 1, Q minus R, Q minus 1, R minus P, R minus 1, P minus Q. Okay. After that, we can see A plus Q, minus R plus R, minus P plus P. So A to power 0. And here in R with R, you can see here PQ minus RP minus Q plus R, and multiply in other part also QR minus PQ minus R plus P plus RP minus QR minus P plus Q. So here we can see there plus PQ minus PQ minus RP plus RP minus Q plus Q plus R minus R plus QR minus QR plus P minus P. So similarly here you can see in further on A to power 0 and R to power also 0, that is 1 into 1, finally 1, that is your required, that is your RHS. That is good. So after that, now taking some another one application question, that is very good question. Question is, if the first and nth term of GP are A, B respectively, the first term is A, okay, and nth term, that means An is equal to B, right? If P is the product of first n term and capital P is the product of first n terms, then prove that P square is equal to AB to power n. This condition is given here and we have to prove this. Okay, first term is A, and now from here nth term is B, so nth term is ARn minus 1, right? The formula of nth term ARn minus 1, it means R to power n minus 1 is equal to B upon A. It means R to value is B upon A to power 1 upon n minus 1. This is the value of R. Okay, now coming to this P. P is given here product of n terms. That means A into AR into AR square dash up to AR n minus 1. Okay, the product of n terms. So we can see here, we will separate A and R, A up to n times to A to power n, and R having power from 1 to n minus 1. Okay, this is, and it is A to power n R, and we will use a sigma n formula here up to n minus 1, so it is n minus 1 into n by 2. So R to power n minus 1 into n by 2. Now here we will put the value of A, which is called A, and value of R, which is B upon A, one upon n minus 1. Okay, this is value of small r from here, and its whole power is n minus 1 into n by 2. So you can see here that this n minus 1 is cancelled. So we will get A to power n B upon A to power n by 2. So A to power n and B to power n by 2, separating the power both A and B, and A to power n by 2. Taking upside, it is n by 2 into B to power n by 2. It means AB to power n by 2. Right? This is the value of P. Now please see here this portion. This is value of P is AB to power n by 2, squaring both sides. So P square is equal to AB to power n, and that is B required. And it's proved. Okay, so that's all for today. Okay, and we will take in another class some other question, important question of GP. Thank you.